Hey, thanks for watching the Jerry Rigger channel. Today's video is about my Coleman cooler. This is the second video I've made about it. In the first video, my plug was getting hot and blowing the fuse constantly. Um, so you might want to go back and watch that video after you watch this one. Um, but I wanted to go into a little more detail of the components because I'm getting a lot of questions about what to happen if your fuse isn't blowing and it's not working. So stay tuned. I'll try and get as much information as possible. And thanks for watching the Jerry Rigger channel. Alright, so we'll start with this plug. This plug has a fuse in it. You unscrew the front of this, the little button, and the screw will pop out. The fuse will often pop out too if the spring hasn't collapsed on you. This one, mine's not coming out, so I'm going to have to pry it out a little bit. But there is a spring down in there. You got to be real careful. That spring, sometimes it'll just pop right out on you, fall out on the floor, get lost or something. So just watch for that. You want to make sure you put that spring back in there. And if your spring is collapsed and your plug's getting hot and you keep blowing fuses, you might want to watch my last video to see what I did. Or possibly you might just want to replace this plug. Also, if you do take this plug apart, be very careful when you put it back together. There is a small ground wire, a little black wire that runs between the ground plates inside the plug. You want to make sure that you make sure that you route that correctly so it doesn't get pinched somewhere by the positive lead. We're going to start by taking the cover off of this. And these screws, they just go into the heat sink. There we go. Alright, so this is a good deal here. They've actually made the connectors two different sizes, so you cannot plug them in the wrong way. I mean, you could try to, but you might get the small connector into the larger connector, but you're never going to get the larger connector into the smaller connector. And that's great because that means you can't plug it in backwards by accident, and I love it when companies do this. Alright, so I am going to go ahead and cut these wires, mainly just so I can take some resistance readings. My cooler is working fine right now, so I really have no reason to cut the wires other than just to take some resistance readings. Because I can't get the resistance readings off each component if they're all connected together. Alright, so one of the first things I noticed is this little white block over here. This is a thermostat, and luckily this is one that resets itself. If it gets too hot, it opens up. It doesn't allow electricity to flow through it. Once it cools down, it resets and it allows it to flow through again. So, and of course, the problem with that thermal fuse is, well, not the problem with it, but if you get these fins all clogged up here, what's going to happen is, this is going to get too hot. It's going to open up. Then the fan's eventually going to cool it back down again, and it's going to try and come back on. But then it's going to get too hot again because there's not enough airflow. It's going to shut off again. So that's going to act like, it's not working. Even though everything's functional, it's never going to get cold. Right, so, and why that's important, right? You see all this dust on this fan? All this dust, and I guarantee it's under the fan as well. This dust is preventing the fan from cooling off the hot side of this plate. What's going to happen is that thermostat, if there's not enough airflow to keep this cool, that thermostat's going to open up and prevent the plate from cooling. And then once it cools down, um, it'll allow the start. Now see, look at all this dirt. Once it cools down, it's going to allow that to come on again. And you're never going to notice this because that thermostat's it's only in line with the cooling plate itself. It's not in line with these fans, so the fans are going to keep running. They're still going to cool it back down eventually, and then, like I say, it'll kick on, kick off, kick on, kick off as it heats up and cools down, heats up and cools down, because it's never going to stay cool enough to keep that thermostat from opening up. So get all this dirt gunk off of there. That could be one thing causing your cooler to stop working. You know, even though the fans and everything are still running and everything looks like it's working, you know, it could definitely cause your, you know, your cooler to not work. And once you get all the major goop off, you know, alcohol and Q-tips works pretty well for removing all the surface grime and cleaning up those plates real good again. You know, the more dirt and grime you get off of there, the better and more efficient this thing's going to work. Of course, and don't forget to clean up the fan as well. Get all that dirt off that fan. And I'm just going to use some alcohol to do that as well. Just be careful. You don't want to put too much pressure on these fan blades. And another thing I'd like to mention, even though, you know, that thermostat is resettable, you know, or resets itself, you know, eventually that's going to go bad if, you know, if it's, you know, just plugged in, sitting there on, you know, flipping on and off all day long, just like your light switch, you know, eventually, you know, it's just going to go bad, just like anything else. So keep in mind that it could open up and stay open. If you look real close at the cooling fins, you can usually see exactly where the screws originally were, so you can get the fan almost in the exact original spot. Alright, to remove the inside piece to access the fan that's inside, all you do is you take this piece and you just pull straight up on it and it'll come right off. Then you can access the fan from the inside. Alright, I am going to go ahead and just take the fan off. Alright, now I did find a couple of sites that sold parts for the Coleman cooler. I know they sold the power cord and they sold the fan for the hot side, but they did not sell the fan for the cool side. But usually if you just look up the model number, you can find, you know, somebody out there selling it. You have to look up the model number that's on the fan that's on your cooler. Otherwise, you're going to have to look up all the specifications, size, and voltage, all that, to try and find something that's equivalent. And of course, what you're seeing here is a close-up of mine from the cold side. And then the fan on the hot side, this is a close-up of the fan on mine from the hot side. Again, you know, check your fan to see what the numbers are on it. All right, here's a close-up of the thermostat that's in my cooler.
Alright, so I did find information on this TowPro BW-ABS, 70 degrees Celsius. So it's going to open up at 70 degrees Celsius, which is pretty common in hot, anything that gets hot. You want to protect it with the thermal fuse, like your dryer would have a thermal fuse in it. You know, appliances that heat up, because they don't want you to overheat it. And if they overheat, you want it to, you know, open up and prevent that overheating. And then this thing's gonna, according to the website, the TowPro website that I looked at, it will reset at 45 degrees plus or minus 15 degrees.
And that's Celsius.
At a, you know, at a lowest temperature of maybe around 86 degrees.
Fahrenheit.
You know, probably going to reset higher than that. You know, 100 degrees, you know, area, Fahrenheit area. But 70 degrees Celsius is around 158 degrees Fahrenheit. So it's going to open and prevent the thermal plate from working at that temperature. And then once it cools down to the 86 degrees, or, you know, 186 degrees, you know, at the lowest, if, you know, it's 45 degrees Celsius plus or minus 15 degrees. So the lowest temperature it should reset at is around 86 degrees. You know, you could try throwing an ice cube on it, I suppose, if you wanted to cool it down, just to make sure that it's reset. But my guess is once it stops working, you're probably gonna have to replace it. But of course, the reason that you would, you know, probably need, you know, or this would probably open up temporarily, is probably because, you know, something was blocking the cooling vents, you know, the fan area, or the, you know, area around the fan. There's, if you look on this, right, you have the area where the fan goes, but you also have these upper and lower vents, and see, these are, you know, see all that dust build up? That can prevent this from cooling properly and then open up that thermal fuse. So, now again, this thermal fuse that sits over here, I took it off just so I could get the numbers off of it. So that could be a problem. Again, if the fans open up and stop working, that could be a problem. There's one on this side, and again, there's one on the other side. And then again, it looks like a pretty simple design. It doesn't look like there's anything that actually controls temperature on this, other than, you know, to shut it off if it gets too hot. It's not a smart, what I would call a smart device, where it would actually control the temperature inside the cooler. Looks like it's probably along the lines of, the longer you leave it on, the colder it's going to get. It probably doesn't have the potential or the ability to get things too cold, or they would probably need some sort of a thermostat on it. But so there you go. If you look right here, see how that metal's exposed? That's the hot side. So if that touches pretty much anything else, including this other side over here, that's, as you can see, is, you know, we could come into contact with either of those if it gets moved around enough. We'll go ahead and do a resistance test on a known good working, since my cooler's working. All right, if you have a meter like this one, we need to turn this, see this little upside down horseshoe? That's your resistance reading. I'm guessing we probably need to be, for this one, in the 200 ohm range. The higher the resistance, the higher I would want to put this dial. A lot of your meters nowadays, the newer meters, they're auto adjusting. They don't have several of these. But I'm going to start there, see what kind of resistance I have,
And currently all the wires are connected together so I can read resistance across this. Okay, it looks like I got really low resistance on here, only about 3 ohms.
Okay, so across these fans, I'm getting about 100K. It's quite a bit of resistance. The other fan, I'm getting almost 200K. Almost pretty high resistance, let's just put it that way. So I must be getting across the cooling plate, I'm only getting almost no resistance at all. Alright, it looks like just a couple of ohms across the plate and the thermostat. Just keep in mind I'm only touching the probes with one hand. I wouldn't want to touch both probes, otherwise I'd be reading resistance across myself as well.
Okay, so from everything I can tell from what I took my cooler apart, this is pretty basic. The you have the fuse, which is in the plug. Um, you have a fan on the hot side, a fan on the cold side, the thermoelectric Peltier plate, um, and then that's protected by the thermostat, which of course resets when it's cools down if it overheats. So, um, if you're taking your resistance readings at the plug, and you have a real high resistance, um, either your fuse is going to be blown, or chances are the thermostat is opened up. Um, I don't know what happened. The thermoelectric Peltier plate. I don't know if it's common for those to open up, but that could be another scenario. Um, the fans they should be fairly obvious. If you have power to them and they don't turn, then you know they probably need to be replaced as long as there's power going to them. So appreciate you watching. Um, don't forget to like and subscribe. I hope this helped you out, and I'll see you on the next video.